Hello, teacher and everyone. My name is Dr. Panat, and my supervisor is Dr. Tadara. Former major is Information and Communication Engineering. Today, I'm very excited to presentation my project about research on smart card to apply in medical system. For my table content are part 1, general introduction, part 2, project introduction, have first background of project, second problem statement, and third objective of project. For part 3, technology and proposed system, have first smart card technology, second smart patient card web, and third solution design of smart patient card network. And part 4, smart card recommendation. For the last part is conclusion and future work. Now move to the part 1, general introduction. Objective of internship. The goal of Institute of Technology of Cambodia is provide the student to find internship after completing the 4 year to improve or practice the student have learned from school before. During my 3 month internship after completing my 4 year at the Institute of Technology of Cambodia, I was obliged to do an internship in order to practice what I have learned from school. And then I got a chance to do research with Dr. Tadara. The research lasts from 3 months, from uh, 26 July to 12 October 2021. For the part 2 project introduction, first background of project. In this world, the automation system in hospital and medical center are become more important every day. That's why they established the idea for hospital automation system for increasing accuracy and led to better service for patient. It has many useful better than better than paper records such as store, analyze, process, and obtaining relevant data from patient information. And problem settlement. The problem that can be solved by increasing the capability of hospital automation system by using intelligent storage and retrieval mechanism. A smart card can play a key role uh, in sharing patient-specific information. So, patients just carry the smart health card with them to the hospital and present it to the doctor for making a consultancy. The third objective of project. The purpose of my research is to find out about smart card tools that are easy to use for multiple functional user in the medical system. It can store patient-specific information, which is a central part of medical system. The media we propose is smart card, whose successful application can also be found in our country in transportation system and telecommunication system. We will refer to such as to card as a smart patient card. And for the part 3, technology and proposed system. First, smart card technology. Smart cards are credit cards which are embedded with an integrated circuit chip contain a microprocessor. The chips are about to store, calculate, manage, process data, and can also hold important information. Moreover, smart cards are safer than magnetic chip cards and performance encrypt algorithm through a smart card reader. Smart cards have wide application in handling of sensitive data such as finance, identity, and personal health information. Second, smart patient card work. First, the patient go to the hospital for issuing card. Smart patient card has patient information stored such as name, insurance detail, primary care physician, etc., and also give a personal PIN code. Inside medical system, the smart card is inserted into card that read the information on the card. Then enter individual PIN code from patient to verify identify to the doctor for improved who can access patient information. After that, the doctor can check or update information and complete full registration, then return card to the patient. And move to the third solution design of smart patient card network. In the proposed system, a single computer represents a computer network in a hospital. There is a smart card read-write unit connected to the computer to record or delete information from smart card, and the write to download, record, and delete information that can be provided by security mechanism. The smart patient card include import medical information of patient. In addition, the chip contains an encrypted code that point to more complete patient information on the web server and can retrieve relevant information about private treatment if needed. If extra or related documentation is kept in a network database instead of in paper form. The accuracy and the speed in the circulation and retrieval of uh, electronic information will be even higher. A whole hospital automation system should meet the following criteria. First, registration, patient file creation, and second, work up daily observation. Third, bedside operation and transaction, and the fourth, access possibility or confidentiality included, and the five, health insurance policy should be integrated in the system, and the last one, online data report by the patient himself or herself should be allowed. Now move to part 4, smart card recommendation. There are many types of smart card, but we select only 3 types for presentation. First, ISO or IEC 7810 is an international standard that defines the physical characteristic for identifying card. And the next one, ISO or IEC 7813 is an international standard codified by the International Organization for Standardization and International Electrotechnical Commission that define property or financial transaction card, such as ATM or credit card. And the last one, ISO or IEC 7816 is a series of standards specified integrated circuit card and the use of card for interchange. Those cards are card identification card intended for information exchange between the observer or the integrated circuit in the card. In my opinion, I recommend the last time ISO or IEC 7816 of smart card to apply for medical system due to it contains smart card and more secure than other card. And now move to the last part, conclusion and future work. In conclusion, smart card can be used anywhere, especially in the field of health, or medical system. Smart card facilitate the work of doctor and patient in many ways. On the other hand, smart card is easy to carry, care, or affordable. In addition, smart card secure our privacy information or sensitive data such as identity ID and biometric information. For the future work, unfortunately, our implementation made some problem and period of project has limit. So the future, I would like to have more opportunity to continue this project to make it know and take it more on implementation to make sure that smart card more usable. And for the next step to learn more about smart card technology to work with smart card to apply in medical system in Cambodia. That's all for my presentation. Thank you for your attendance. If you have any question, you please ask me. Hello, teacher. And
Okay, thank you, Panat, for your presentation. You did the research on smart card, right? So, can you just clarify again what is the goal, the main aim of of using smart card comparing to using a normal document or the existing system that we have?
thanks for your question, teacher. The usually way of obtaining relevant data is from paper record. Uh, the paper record based record have allow cost and have a limitation such as difficult to access, time consuming to update, secure, impossible. But smart card easy to update or update information and it's easy for patient to carry and doctor can doctor also can check the information of patient uh, can delete or update it. It's easy than a paper record.
Okay, thank you. So you mean that inside that smart card, the the medical history of the patient can be stored inside that card, right?
Yeah, teacher.
The whole medical history.
Uh, Teacher, can you ask again, teacher?
ខ្ញុំចង់សួរថាអញ្ចឹងមើលថា smart card របស់យើងហ្នឹងគឺផ្ទុកព័ត៌មានបានច្រើនណាស់ហើយទៅគឺផ្ទុកព័ត៌មានប្រវត្តិជំងឺរបស់អ្នកជំងឺហ្នឹងតាំងពីដើមមកហ្មងបានទាំងអស់ហ្មងហ៎
Yes, teacher.
Okay, good. And have you ever okay, let's just one simple question. And what if the patient lost their smart card? What he or she gonna do?
When she or he lost the smart card, she or he can contact to the hospital for create a new one for there.
And how about their medical information? It is gone with their smart card, or the hospital has to keep their data inside their system.
The history of information patient is recorded on the system on the data server, the database server on system in hospital.
Okay. Okay អញ្ចឹងបើ medical history ហើយនិង information ទាំងអស់ហ្នឹងវា store នៅក្នុង system របស់ hospital ដែរអញ្ចឹង smart card របស់យើងហ្នឹងគឺគ្រាន់តែជាដូចរបៀបលេខកូដមួយ patient ID មួយដើម្បីទៅ access ចូលទៅក្នុង database របស់ system ដដែលហ្នឹងហើយទៅខ្ញុំឃើញមន្ទីរពេទ្យមួយចំនួនធំឥឡូវហ្នឹងក៏គេមានគេគ្រាន់តែមានកាត់ជាกระดาษ plastic អីទូចមួយល្មមមានតែ page ឈ្មោះហើយនិង patient ID ហើយទៅគេក៏អាចដូចមន្ទីរពេទ្យជប៉ុនអីហ្នឹងក៏គេមានណាស់ដែរតែមិនដល់ថ្នាក់ដល់ smart card ដូចពេកទេចឹងបើព័ត៌មានទុកនៅលើ system ផុសhospital ដែរអញ្ចឹង smart card នេះគឺគ្រាន់តែជា identity card មួយដើម្បី verify អញ្ចឹង
Okay, Panat, can you answer?
Well, teacher.
Okay. Okay. Well, for like this, actually the smart card that he talked about, maybe he misunderstand about the some conditions that using the smart card it doesn't store the medical data. It works to store the private key and in use for the encryption. Yeah. And the private key is used for decrypt the medical data in the systems.
Okay, got it. So all the medical data are stored inside the system, but no one cannot access it besides having that smart card, right? That is secure.
Yes.
Okay,
yes.
that is the main goal of that smart card. Okay, thank you.
And yet, Bong, actually for the Panat, he worked on the reviewing the architect use case of the using smart card and smart card types and some like scenario maybe he misunderstood. Yeah, like losing or something. He didn't go through it. He just reviewed how to use smart card in medical. But actually it depends. Like some smart card, it doesn't use like private key, just use like QR code, like you said in the bad year they use QR code, but it doesn't use private key.
Okay.
Yeah.
Okay, and just one last question. If the system work can it be used for multiple hospital? Let's say one patient single carry a single smart card, but can he use for different hospital?
Yeah, teacher. Because the proposed system represent a computer network and store the data to the server.
Okay, thank you. So I got it. So it could be some sort of a centralized data that, yeah, to use a multiple places. All right, thank you. That is all for me.
Thank you, teacher.
Okay, maybe I just ask one question, and since I think since you didn't understand clearly maybe the scenario of how it works, how it actually works in the real case, maybe I will ask you your recommendation here. So you recommend the last type of smart card. Can you explain more why you choose the last one? Why you said that it is more secure than the other?
And for your question, teacher, the ISO EDC 7711 is
What does it have? What does it have that the other card doesn't have?
inside the card have a microcontroller, microprocessor, or a memory chip that contain compressed and encrypt data that can be read from or write from at point of care. Use an intelligent reader into a system.
So you're saying that the other card doesn't have this microprocessor? The first two?
The first and the second have two, but it focus to a specific physical characteristic like
Okay, so I think maybe I think Pandit maybe had difficulty to explain, and I want to make it clear because it's time's up already. And for the card of the 7810 and 7813, those cards work well. Actually, those I mean, like 3 cards, even 7816, it using it's used the IC card, like the chip, micro chip, but for 7810 and 7813, it used like for identity, but it's not work for the cryptography. So reflect to the first answer that we work on the cryptography, private key and public key. So we use the 7816.
Okay, well, yeah. I see.
Yeah. So I think we can move next to the second person because maybe it's hard to for Pandit to answer. Thank you. Yeah.
Okay, so let's move to the second presenter. Is Marlene. Okay, let me find your updated video. I just downloaded it.
Hello, Twitter, and hello, everyone. My name is Lina Lin from ICATSIC. Today, I would like to present my internship at Lab Information and Security at the Institute of Technology of Cambodia. My topic is about smart card, and my supervisor at Ivershaw during the internship is Dr. Tet Dara, that will start from 26 July till 12 October and 2021. Before I started to present my about topic, I would like to present I would like to show about my content first. There are four parts in my content. The first is internship overview. Second is smart card ISO or IEC 2816 from part 1 to part 8. 3 is about ECC, and 4 is about conclusion. About my internship overview, I would like to show you about my company information first. That is the Institute of Technology of Cambodia, or we call ITC, which is a Cambodia Public Higher Education Institute or a prestigious Institute of Engineering and Science. ITC was founded in 1964 as the Superior Institute of my Soviet friendship. There, the location is along the Boulevard, Russian Boulevard. And another one is about my department information. I study at SIG information at SIG department, or we call department de Informatique et Communication, or in English, it's about Department of Information and Communication Engineering. Was founded in 1998. About my department SIG, it provides engineering and master degree for students who would like to study about technology and science. And my lab of information and security is at building I, sixth floor. About ECC smart card, about smart card of 2816. As my another member was mentioned that this smart card was useful for my for the e-health and for e-health. So and he was mentioned about it already. So this for now in my presentation, I would like to describe from each part in this smart card where is health 15 part, but I just include only from part 1 to part 8, and then the remain for my other member will be present in the next version. The first part of ISO or IEC 78 or 16, this is about the physical characteristic. This part we focus on the strength mechanism or dimension. It's like we want to tell you about the standard of smart card which we use. About this smart card, we also do it like the standard is we use IDs 1, which is the dimension 85.6 millimeter, and this type of smart card you can available another card is like credit card or debit card, and this type of card is only thickness just only 25.75 millimeter. This part 2 is about dimensional allocation. This part we focus on about the pin interface of smart cards. For 78 and 16 cards, we the designer design with 8 pin allocation, and each pin allocation is all its own task. It's like It's like VCC or reset a clock, ground, import or output a data or application specific. And for the count, for the pin located count, we count from the bottom to right at or the corner. In this part, the part 3 is about the electrical interface and transmission protocol. This part, we respond about the power and signal structure and another part is information exchange between integrated circuit and interface device or terminal. It's like the part 2 the same. In the part 4, we focus on about the organization, security, and command for interchange. This part, we focus on the content of the command or response pair exchange and the interface that we use or which command or method that we want to access in that smart card. The method for secure message or structure of application that we apply in this part. With the part 5 is about the registration of applications provider. This part is focused on the show of how to grant the unique application in identifier through the international registration of a part of the identifier and define. It means that when the user try to register the application from in the smart card, they will be stored in it. It's available. In the part 6 is about the inter-industry data element for interchange. This part we focus on the identifier, the following characteristic of each element, it's like a description, different format encoding, identifier or names. This part we based on the ICC, both contact and contactless smart cards. In the part 1 is about the inter-industry command for structural card query language. This part is focused on the grammar or XUR when we want to know about the result of processing statement language during this apply the inserted data. So it means that we want to check that whether our grammar is right or wrong when query data. In the part H is about the command and mechanism for security operation. Part A, we focus on the inter-industry command and that many use for security operations. And once more is about the evaluation of about the digital signature certificate or the import export that of the asymmetric key. After I described about each part from Smart Card ISO IC78 or 16, now I would like to describe about ECC, we call elliptical cryptography. During for the security part. About ECC is an approach to public key cryptography that based on algebraic structure or elliptical over finite field. ECC is like we will allow the smaller key compared to non-ECC to provide equivalent security. About ECC, we first will learn about the history of ECC first. Slide ECC was suggested by Neil Collip, who is a professor of mathematician at University of Washington, and Victor S. Miller is an American mathematician at the Center for Communication Research in 1985. About the objective of ECC. As we described before, is related to the algebraic structure, and now ECC is the part after research and many after got a many research from other researchers around the world. We got a new conclude that ECC is the new cryptographic that based on development for increasing that security and more robust network performance. It had to establish the right security that greater than RSA or DSA. Why this ECC is so secure from the more than RSA and DSA. Now this brings more because of that the ECC one it can provide as much of security like 164 bit us as the system can account 1024-bit key. And one more thing is applicable for key agreement, digital signature, and first for random number. For this part, we try to understand about the Diffie-Hellman. The Diffie-Hellman is the first public key algorithm which support to enable two user securely exchange a key that can be used for subsequent symmetry encryption of message. It's like when two users want to make a share secret key using the online. Like the example, Alice and Bob want to share a secret online. Then they must generate a public or private key pair and distribute the public key. About this part is about ECDA, or we call elliptical Diffie-Hellman. This part we use ECDA for encrypt data, and ECDA is based on Diffie-Hellman too. ECDA is a key agreement protocol that allows two parties each having elliptical public-private or public key pair to establish a shared secret over an insecure channel. Like the example, suppose that Ali want to establish a shared key with Bob, then each party must know each other party public key prior to execute the protocol. This part is about ECDSA. For ECDSA, or we call elliptical digital signature or algorithm, we use to sign digital signature, which is required twice security right in the bit side or the public key. It's like that we want to sign signature by the digital area. So we use this part of the ECDS to apply the security on it. Another example is about that. At the security level of 80 bits, means the attacker required maximum 2 multi-active operations to find a private key if they want to access through that private key. About the conclusion part, during my internship, I faced some difficulty and experience that I would like to express. The first is about my difficulty. As a researcher, we would like to say many more documents, including the tutorial website or the book. So, but most of the document is very far from the new technology that we apply in nowadays, and most of the researchers who are our biggest rate, they are so far from now. Maybe it's so around that 10 years. So it's hard for us to say about this. And another thing is about some feature. After we search about document or we try to test it for our testing card, we got some error during the implementation. However, sometimes we try to find the solution from the old tutorial or some document, but not most of the feature is not available for our testing. Another experience is that after I joined, I got more improving skill of research, and I can working on a team and communication, especially for the problem solving with my teamwork when we test it, and got some advice from my teacher, my advisor. And another thing is about the new work environment and responsibility from the way I did in my internship. For the three part is about the perspective. My perspective is about that I would like to improve performance and programming language more in the next time when I got a time to develop in this market. And especially add more developing programming. For my future work, I will try to collecting more information and data to validate the case, and once more to apply the Java programming language in Smart Card. We use Java template that for the programming. Thank you for your precious of time. Hello, teacher, and hello, everyone.
Okay, thank you for your presentation. So maybe I will start the question first. First, could you tell me maybe in more detail what is your responsibility in this project? You work with other teammates, right? So what is your responsibility?
I'm sorry that I didn't mention in my slide, but about my responsibility during the internship is that my part is about to study about history of smart card, with this smart card that suitable for our medical system when we need to develop in future, and then I choose 70A and 16 part for my project. After I choose it, I try to understand each part beside the 70A 16. For this part, for 15 in 20A and 16 part of this smart card, there are 15, but I only describe each part. Another domain will be presented for my friend, and another one is I search about asymmetry cryptography. Besides asymmetry cryptography, there are Diffie-Hellman, ECC, and OSA. But I only describe about the Diffie-Hellman and ECC first. So the remainder will be presented by my friend.
Okay. So maybe I want you to explain me again can you tell me maybe a step-by-step process how your project or your system works when you successfully implemented it, starting from the scratch. Okay.
To tell me about the implementation or about what I researched in this smart card.
The implementation of the whole project. I want to know how you understand the big picture of this project, how the smart card work in real case. Can you elaborate on this?
Actually, I think that for the researcher, we want to find the smart card, which smart card is best for our medical system. So we choose 78 and 16. And after that, when we do research about this smart card, we try to know that there are 15 parts besides this smart card. So we will choose which part can handle with identity and secure for the next part for the implementation when we have a time for develop. And yes, and then we try to understand about we want to apply the asymmetry better than the symmetry, because symmetry is about a private key, so it may be not secure like the asymmetry. So we try to research about asymmetry, and beside the asymmetry there are two, OSA and ECC. That's why. So am I right with the question you asked, or it controversy?
Okay, it doesn't actually answer, but it's okay.
Besides, I want to try to elaborate a little bit that in this stage we work on the research choosing the type of the smart card and the cryptography algorithm only, and for implementation after we succeed this.
Yeah, okay, well. So can you tell me what will you do next?
My next future work slide, my teamwork will be trying to apply the programming language beside and one more thing, that we will try to find the solution with our implementation, because our implementation not success by the insert smart card to download driver to our smart card. So the first step for our implementation was error.
Okay. Maybe I want to know a little bit about this system. What is the physical device that you need in order to implement the project?
We use a CR39U8188 device driver for reading smart card. It's like a USB interface to connect from the card to the PC, and then we try to find insert the implementation like programming beside it. Yes, these are.
Okay, yes. Okay, that's all for my part. Tin, do you have a question? If you have, please ask.
Okay, thank you for the presentation. Actually, I don't really get the. I know you do a research on the smart card, but okay, my first comment is about the presentation slide. It's a little bit difficult to follow. Even the section number and the page number you didn't include inside the slide. And by the way, I have I don't know how you implement the encryption method. What you call DFIR? How do you implement this? You haven't implemented yet, but how, for your concept, how it works with your smart card?
Could you repeat again, please? I didn't catch it.
You say, yeah, that you see on the screen. You see this is the encryption method, and how you really, I mean, not implementation. It's the concept how it really work with your smart card.
Determine how like a little
Yeah, how you use
send
this,
the message and then encrypt or decrypt.
This is about the message encryption, or it related to your smart card? Actually, your smart card is the ID card.
Actually, like a teacher, a smart card is the way that we use to store identity or name or everything beside it when we succeed in the testing or apply it in the e-health center. And the picture is about that one. We check an example. When Ali want to send a message to Bob, and then Bob, if Bob want to get a message, he must to have a private key or a secret key from the Alice. And this one is like that. And for the smart card, if a user like our patient got a card from an e-health center, then he or she must be insert the registration for their identity to identify that they are this patient or that person to notice when they got if they are go to the hospital again to check their health. And the another one is think that when he want to connect to the smart card, or he insert the card to the machine to try to show who is he or she, then he must to have the secret key or the private key to encrypt that it. That's my this picture is just only an example, and the implementation is the same like the example two.
Okay, in this picture, your smart card is which key? Is the public key or the private key? Can you answer that?
I would like to explain again. Like asymmetry, it apply both private key and public key. So if we, when we want to encrypt that data, we must to have the private key to encrypt that public key. In asymmetry, they have to wait like two pair to encrypt or decrypt data. It means that it must be secure than symmetry, because symmetry just use only private key. It's like the only one password to set it. And another one picture like the curve plane. Next picture is that beside ECC, it has not only ECC. In asymmetry, it has signature digital or data digital, like if we want to encrypt data or we want to encrypt that signature. It's like example, like when teacher go to the ABA bank or Aslida bank, teacher want to register for the credit card or Visa card. Then they will ask you, teacher, would you like to sign in the letter or would you like to sign in the signature? And the signature will be or that data will be considered like generate in the computer machine, and this way we use the digital signature for that signature, ECDSA, this for signature, and will encrypt data that if the just want to define that he is that person who he is the owner of that password or he is the owner of that Visa card, they use ECDA. This is the answer I give.
Okay. And anyway, actually, I know the encryption method on the end-to-end encryption. It works the same way as this one. Okay. Let me go to another question. In order to access the historical medical information, medical history from the system, the doctor needs the smart card. They must have the smart card in order to access the information.
Oh, can you repeat again, please? I didn't catch. Sorry.
Okay, when you, I mean, in the system, the doctor need your smart card in order to access your medical history.
Yes, it's like that. When we want to insert to check, like you want the patient who come to the hospital or go to the hospital to check your health, and then you must to identify your identity. So you have to you just to check it. If maybe in the future they can have another platform like application to they can check on the phone, but now maybe just only the smart card first start to check it, like who you really are first.
Okay, but
Yes,
I think not in the future, but for now you can implement it with the application or something like that, because I think they already have the existing application to verify the patient in order to access the information. But I think another difficulty is like that if it is the must to use the smart card, there will be problem if you stay far away from your hospital. Maybe your hospital is in overseas. Maybe they want to access your information. It could be difficult for that. Maybe they must have any account, like, in order to access the information. So I think that okay, I think that that's all for me, and thank you for your presentation.
Teacher mean that if we want to know who are the patient, we have to have the smart card to check, or we just only say something to the doctor and then the doctor can confirm who we are, right?
I mean, okay, let's say if I want to give my information to my doctor in another country, and my card is with me right now, and they want to know my information about my medical record, and what can we do?
In this case, like we want to transfer our information to another country. It's such like first when we got the smart card, like to confirm our identity, then we must be registered in the information from the organization first, like who we are, where we live, and what kind of the disease that we have or we face or we want to check the health. It means that we have to have the paper, and then we got the smart card to confirm that it's if you are stay in the Cambodia and you want to check in the Singapore, you just only tell the doctor about who you are, what's your name first, and about your identity, like your smart card like number, smart card number, or the patient or the disease that you ever first, and then the doctor at another country will be check it during according to that. But if they don't find, they may be send you to like to got a receipt from you or from their history or receipt that they keep in that hospital. So it must be confirmed by that way. And another thing that is the next future, medical health is popular and got more support from our institution. Maybe they can develop to use in the application tool to like we use smart we use ABA Bank in mobile and smart and Visa card or Mastercard in our hand. It is the same in the future.
Okay, if you say that you can use your ID card, your smart card number to verify your information, I think maybe your smart card might be useless sometimes. Why not using our national ID card, because they also have the unique number in order to verify that?
Actually, that is smart card that we choose to apply for e-health because this apply both contact and contactless smart card. However, some hacker like want to hack, it may be hard for them. Especially we apply ACC, we apply asymmetry beside it. So the encryption or decryption for this card must be secured. And another one that determines that maybe I can consider 78 and 10. This is about this is another type card. That smart card that it's not applied in both contact and contactless smart card. Like it's not secure as this 17 and 78, 16 smart card. That's why we choose the card to our performance and security.
Okay, because you said like you can use the ID card number to access for the overseas doctor to access your information. It means like your secret key or your encryption method inside the card will be useless. But anyway, the hacker, I don't think they try to hack your card, but I think they try to hack your system server instead. Anyway, thank you for your answers and your presentation.
Okay, I want to ask a little bit. Can you tell me how many times this key are generated? Like when does it generate the key? One time or many times, or how many times in the smart card?
About this picture, right? It's like the first, according to that, ECC is depend on the asymmetry, so it used two way to decrypt. Therefore, we need to encrypt it in the simple way. Like we need to encrypt in public first, and then we need it to encrypt in the private key. It means that maybe 2 or 3 times for the path for it. According to the message or according to the data element need.
So many times.
Maybe 3 times. About encryption, teacher, it's maybe 2 or 3 times.
Okay.
Okay, so I think I want to clarify this. To encrypt the data, it's case by case that when use the private key to use for the digital signature, and we use the public key for data encryption, or we use some kind of we merge those keys together and get another key for the data encryption. It depends on the case. So for they say like two or like several times, it depends that we have to encrypt the symmetric key and then encrypt with another asymmetric key. It depends on the security level you want to apply.
Okay, well, thank you.
Yes, and
So-
extra that it for the encrypt or decrypt method, it depends on the structure, like we want to encrypt or decrypt it. Like if we want to decrypt method, we use ECDA, and signature we use the ECDSA, and the slow and the like equation is maybe different too.
Okay, thank you. So we want, okay, let's thank you, Madeline, for your presentation. Now let's move to the next presenter. Yeah, behind your screen. So the next presenter is Sophia. Okay, let me find your video.
Good afternoon, teacher and everyone. My name is Meng Sophia. I will be present about a topic on smart card, which I have researched so far under my supervisor, Dr. Tadara. The table contents included technologies and tools for report, general presentation, project presentation, operating system, ISO or IEC 7816 from part 9 to 15, RSA to apply on smart card, including generate both public and private key. The technologies and tools that I have used are Microsoft Word, which is mainly for typing and design table contents. Zotero is the tool that helps you to collect and manage and cite your references. And Google Doc to save and update report on a different device. Google Slide to save and update slide on a different device. RSA expression encryption or decryption calculator to calculate the decryption and encryption. The first part is the general presentation, which included the objective of internship, as we have known that the goal of ITC is to provide students a quality engineering, science and technology training and education. Students will possess the practical hand-on skill and soft skill that prepare them into the labor market. The duration of my internship is approximately 3 months. I did my internship at Institute of Technology of Cambodia under supervision of Dr. Tadara. So we have a project presentation. First point is the general project, which explains what is a smart card. A smart card is a tiny computer and is proven to be useful as a transaction or identification. As smart card grows, it can be used to replace items or things. We can use card instead of cash, license instead of identification certificate. The second point is the problem is that threaten our personal information has increased, as thieves and pickpockets can easily steal your wallet or important file that is related to business, companies, or personal information. The last thing is the objective, which is to improve our security of our personal information and files, as we know that smart card can be used to prevent our identification and authority of the cardholder. For the operating system of the smart card microprocessor must handle tasks included data transmission over the bidirectional and serial terminal interface, loading, operating, and management of application, execution control, and instruction processing, protect access to data, memory management, file management, and the last one is management and execution of cryptographic algorithm. Unlike personal computer operating system, smart cards do not feature user interface or the ability to access external storage. Now this part is to explain about the ISO or IEC 7816, which included 15 parts. I will be explaining from part 9 to 15. So the ISO or IEC 7816 is an international standard related to electronic identification card with contacts, especially smart cards, and more recently contactless mobile device managed jointly by the ISO and IEC. The ISO 7816 Part 9 commands specific on card, file, and other structure management. These commands on the card are for entire life cycle of the card, which means that sometimes the command was used even before the card was put into the card holder or the card has already expired. The ISO 7816 Part 10 specific for power, signal structure, and structure for the answer to reset between the ICC with the synchronous transmission and interface device like terminal. It also covers signal rate, operate condition, and communication with the ICC. This part of ISO specific two types of synchronous card, which is type 1 and type 2. The ISO 7816 is security-related command to be used for personal verification through biometric method in ICC. It also defines the data structure and the data access method for the use of card as a carrier of the biometric reference and as a device to perform verification of the cardholder biometric probe. The ISO 7816 Part 12 shows us that the electrical condition when a USB ICC is operated by an interface device for those contact fields that are not used when the USB interface is applied. The USB standard descriptor and the USB ICC class specific descriptor. The data transferred between the host and the USB ICC using buck transfer or control transfer. The control transfer, which allows two different protocol named version A and version B to transfer to each other. The next one is optional interrupt transfer to indicate the asynchronous events. The last one is status and error condition. The ISO 7816 Part 13 specific command for application management in a multi-application environment. This kind of command is used for entire lifecycle application in multi-application of the card. It can be used before and after the card is issued to the cardholder. This ISO does not cover implementation within the card and the outside world. The ISO 7816 Part 15. This application contains information on cryptographic functionality. It also defines a common syntax and format of the cryptographic information and mechanism. It also coordinates the component running on various platforms, enable application in the outside world to take advantage of the product and component for multiple manufacturer, enable the use of advanced technology without rewriting the application level software, and it maintains consistency with existing related standard while expanding where it is needed. It is also support the storage of multiple instances of cryptographic information in a card, cross-reference of the cryptographic information with the DOS, retrieval of the cryptographic information, which is the key factor for this notion of the directory file, different authentication mechanism, and the last one is the multiple cryptographic algorithm. This part is to explain about how RSA apply on smart card. The objective of RSA is to make our data or message more secure by adding encryption code in the message. There are two keys in how RSA works, which is public key and private key. The public key can be shared openly to the public and anyone can access it, but only people with private key can decrypt the code and read the message. RSA encryption is a bit different from symmetric encryption. While symmetric key encryption use the same private key to encrypt and decrypt the message, but both RSA need both public and private key. RSA often seen used with another encryption or for digital signature. RSA wasn't used to encrypt the whole file or entire message, but rather used as the encrypt of the encrypt message to make it more efficient. Because RSA is a more heavy resource, this is used to keep the file and message secure without consuming too much time and too much computational resource. RSA can be used in different systems such as OpenSSL, WolfCrypt, and a number of another cryptographic library. It's also laid as the foundation of many secure communication. It was founded in 1977 by 3 men, but was approved in 1983 by the MIT. The word RSA are the initial of their last name, which are Rivas, Charmier, and Adamant. RSA encryption uses prime number that are large in magnitude and a few other complexity. RSA encryption works under the statement that the algorithm is easy to calculate in one direction, but almost impossible to do it in reverse. This is called a trapdoor function. So basically, it forms the basis of how public and private key encryption work. First, we have to generate a prime number. We have the following formula of n equal to p multiplied by q. We pick two prime number, which is 101 and 107. As a result, we got 10,807, which is the module. The next one is to use the Carmichael-Toshan function, which we have a formula of Carmichael-Toshan for n equal to the LCM of p minus 1 and q minus 1. Now we got a least common multiple of 100 and 106. As a result, we got the Carmichael-Toshan function equal to 5,300. For the next step, let us generate the public key. As the formula is shown to be C equal to m to the power of e mod n. The public key is shared openly. It's not so important for e to be a random number. E is generally set at 65,537, and the mod is the modulo operation, which means the remainder of the leftover. Let us say that the message m is a single number equal to 4, which we want to encrypt and keep a secret. To make an example easy, we will be using e as 11 as an example. So we have 4,194,304 to the mod of 10,807. As a result, we got our ciphertext equal to 1,188. Therefore, when we use the RSA encryption, our message 4 with our public key, it gives us the ciphertext of 1,188. The next step is to generate the private key. In RSA encryption, once data or message has been turned into a ciphertext with a public key, it can only be decrypted by the private key from the same pair of key. Private key are composed of D and N. This equation may look like it is asking you to divide 1 by 11, but that's not the case. Instead, it just symbolizes that we need to calculate the modular inverse of E, which is 11, and the Carmichael-Toshan function, which is 5,300. As a result, we got D equal to 2,891. It's the decryption key. After we got the value of D, we can decrypt messages that were encrypted with our public key using the following formula, which is m equal to c to the power of D mod n. As we know, C is equal to 1,188 and N is equal to 10,807. But trying to take a number to the power of 2,891 is a bit too much for a normal calculator. Instead, we will be using a RSA Express encryption or decryption calculator to calculate the decryption and encryption. In the calculator, we enter 10,807, where it says the supply modulus n, 2,891, where it says decryption key D, and 1,188, where it says the ciphertext message in numeric form. As we got our decrypt message in a numeric form of 4, which is correct as the number we have set before. In conclusion, I have improved my understanding toward different types of cards to be able to understand more about the process of encrypt and decrypt. Also gain experience as a researcher. Last thing is I was able to work as a team. In our future work, since we have already spent most of the time in implementation, but unsuccessfully, we would like to finish our implementation in the future and hope to have a good result on it. Thank you. This is the end of my presentation.
អរគុណលោក Professor បាទ Thank you very much for your presentation. អរគុណលោក Professor បាទ Thank you very much for your presentation. អរគុណលោក Professor បាទ
។
Okay, thank you, Sophie, for your presentation. I don't think I have any technical question regarding this encryption method. So maybe you can tell me a little bit about your responsibility in this
So
project.
my responsibility is to study like different type of card and specific on the 7816 from part 9 to 15, and then I continue to study about how RSA apply on smart card, the process of RSA, how do they generate code.
Okay.
Oh, sorry. Yes, teacher.
So there are many encryption methods besides RSA.
Yes, teacher.
How many did you look into?
I have seen 3 of them, which is ECC, the one Marilyn just said, and I focus on RSA, and there's another one which is DSA, but we are not focusing on that.
I see. So based on your understanding, between 3 of them, which one is the one you
better?
recommend? Yeah.
We study like Marilyn study ECC and I study RSA, and I have searched both of them, and I prefer ECC because ECC provide equal cryptographic strength with far smaller key size. Around the order of magnitude is smaller. Because ECC use a shorter key length, it requires less processing power to decrypt and decrypt data. Make it excellent fit for mobile device, the Internet things, and other use case which for example our computer is restricted, so we can use ECC. Also, the performance when it comes to RSA, it's generally reported to be 10 times slower than ECC for a private key operation, such as a signature generation or key management. And one more, RSA key generation is very slow compared to ECC key generation. They said that it is around 100 to 1,000 times slower than ECC. Yes.
Yes. Okay. I never know about the smart card. Does it have storage? What is the capacity does it can store?
For the normal smart card, it store around 1 kilobyte to 256 kilobyte. But for the ISO 76, most of them are 60 gigabyte and some of them are 72 gigabyte.
Okay.
Yes.
Okay, thank you. That's all for my question.
Thank you.
Didn't you have a question?
Okay, I have some questions because I don't know, all of you work mostly on the same topic, but I don't know how you manage your responsibility. But in this presentation, I think you focus on the encryption method. Can you explain? I don't really understand how they apply the encryption method inside your smart card, because in this method we have two sides. Maybe we have to share the information to each other. And can you explain the real case of the smart card implementing with this encryption method, like maybe in the smart card in which side and in the hospital, and how it works and exchange the public key and private key?
Is this a little bit too out of my scope to answer about the medical, but I can answer you how to encrypt and decrypt. If we move a little bit to slide RSA. Teacher, can you move to RSA slide?
Okay, actually you work on the smart card and you do the research on how to use the smart card. Yeah, in that.
So first we generate 2 prime number. Okay, teacher, we get the module, we multiply, and then we move to the next slide. It's shown us that we use the Carmichael torsion function, which we use the lowest common multiple. And then we move to the next one by generate the public key with the formula that is given by the RSA. And then after we generate our public key, we got our ciphertext, we move to the next step to generate our private key. And then after we got the private key, since yes, teacher, after we generate our private key, we have the formula which power to the 2000 plus, which a normal calculator cannot generate. So we use the RSA calculator, which can you check it? Yes, which we have our decrypt message in numeric form is which is number 4, the one that I set number 4 to make sure that my calculation is correct.
Okay, actually, I know how it works in the encryption method, but can you go to the page 16?
Okay, teacher.
Yes. Between the sender and the recipient, and this is the example use case, but you implement it inside your smart card, and in your smart card, in your system, which one is the sender and which one is the recipient, and how they exchange the public key and private key? Do you know the process of that?
Sorry, teacher.
Okay. Okay. Again. You see in the figure, there's the sender and the recipient. But this is the example of the encryption method, how to exchange the public key and the private key. But to be honest, I don't really understand when you apply it on your smart card, how it works. Like how your smart card exchange like the private key or something like that, how it works.
We use Delphi-Hellman to exchange the public key.
Use what?
Delphi-Hellman from Marilyn.
Okay, can you describe the process of, like, I think in this encryption method there are so many processes, like, okay, first you have to issue the public key and then generate the private key and then you share the public key to each other, and then when you receive the message from the other side you have to use the private key in order to decrypt the message or something like that. But I want to know exactly in your system and how it works and how they exchange the information by using the encryption method.
I will learn more about that because we do not work on that system, teacher.
Yeah, it's okay, but I recommend you, because you do the research on this part. You should know the process.
Yes, I understand, teacher, but we are working on algorithm, and we will accept your suggestion, and we will continue to work on the system.
Okay, thank you for your
Thank you very
I don't
much,
have
teacher.
any other questions.
Thank you, teacher.
Right, thank you, the presenter, for your presentation. You have done a great experiment on the OSA, but have you ever considered about the attacking the OSA?
Can I answer? OSA is to make our data and message more secure. So we can do by the trapdoor function, which means that it works under the statement that the algorithm is calculated in only one direction, almost impossible to do in reverse. It forms a basis of how public and private key encryption work, teacher.
Okay, but have you ever heard about some sort of plain tick attack like that?
Not yet, teacher. Not so far in my perspective.
Okay, just keep this in mind. But you can do the research later about the plain tick attack. Okay.
Okay, teacher.
All right. So for me, I don't have any other question. So thank you.
Thank you, teacher.
Right. So if there's no more question, Sean, so we move to the last presenter, please.
Yeah. The last presenter is Dararat. Okay. Let me find your video.
Hello, teacher. Hello, everyone. My name is Khon Dararat. Today I am really excited to do the presentation about my fourth year engineering internship. Its topic is about smart card technology, and my advisor, also my supervisor, is Dr. Tet Dara. And here is the content of my presentation. First, the introduction, which cover internship overview about smart card, problem statement, objects of research, research methodology, and the tool for report writing. For the second is about technology and why we use standard ISO 7816 part 11 and the comparison of OSA and ECC, the tool for implement and implementation. The last is the conclusion that conclude the difficulty summary of research and the future work. Now let's go straight into introduction. For my internship overview, my internship took place at the Laboratory of Information Security and Application Design located at IDC under the leading of Head of Laboratory, Dr. Dara, and my research field is about smart card technology, and the duration of internship is about 3 months long. For the next is about smart card. We have already known about key component of smart card and its overview that is presented by the previous presenter of smart card technology. Now, let me briefly describe about smart card. So, smart card or chop card or integrated circuit card that we can call ICC or IC card is physical electronic authorization device used to control access to a resource, and it widely used in many sectors of society, especially to preserve healthcare service, banking and retail, mobile communication, and also citizen identity. As we can see in the picture, the bigger one is the card in form of credit card, and the smaller one is a card in form of SIM card that we use nowadays. Let's move to the problem statement. So nowadays technology is extremely modern. By the way, the rate of crime is tremendously increasing every day globally in different fields of life, result to human insecurity, fraud, counterfeiting, robbery, cybercrime, and a whole lot of other ways in society. That's why we create a smart card. For the research objective, the main purpose of the research, we would like to survey all types of smart card and consider which one is the best for preserving citizen identity. Let's move to research methodology. In the process of figure out the objective of this research, we have followed the described lines of my supervisor, Dr. Tet Dara, step by step. For the first 2 weeks, we read and understand about the objective and collect the card data. And for the second week to the 8th week, we apply use case and study about the related technology, which takes about 6 weeks. And for the last, we do the implementation and report writing. The duration is about a month. About tools for report writing, we based on 2 tools that we use Microsoft Word to writing the report and also to arrange the content of our report. And also we use Zotero to have to collect and also organize the citation and arrange the reference. For the technology and why we use ISO 7816 part 11. Based on the research, ISO 7816 part 11 is considered the best among of 15 parts. According to its benefits, quality, and its security, and the comparison of OSA and ECC. So OSA and ECC that we know that it has their own benefit. By the way, ECC is better than OSA according to its key encryption techniques. As shown in the diagram, ECC provides equal cryptographic strengths with far similar key size, around an order of magnitude smaller. For example, an OSA 2048-bit key would be required to obtain the same cryptographic strength as 112-bit symmetric key, while an ECC 224-bit key would be suffix, because ECC use shorter key length and it requires less processing power to encrypt and decrypt data, and making it an excellent fit for mobile device and also Internet of Things and other use cases where the computer power is restricted. When it comes to performance at 128-bit security level, OSA is generally reported to be 10 times slower than ECC for private key operation, such as signature generation for key management. Let's have a look at PKI. PKI is known as Public Key Infrastructure. Is a system of processes, technologies, and policies that allow to encrypt and sign data. And furthermore, PKI system is more secure than password-based system because there is no shared knowledge of the secret, and the private key need to be known in one place rather than two or more. If one place is smart card, so the private key will never leave smart card, and smart cards will always allow for the privacy key to be usable and yet never appear on a network or a host computer system. For the tool that we use to implement, we have do a research and found a lot of tool and technology that are used to testing and implement, such as Java card based on standard ISO 7816, card reader, NetBeans IDE, Java JDK, Java Card Development Kit, and Java Card Platform. Now we are in the implementation. For this implementation, it requires NetBeans IDE version 6.8, that is the old version of NetBeans, and also Java Card SDK version 3.02, and Java Card plugin for NetBeans, and also Java Card JDK version 6. That most of them are the old generation technology. That's why it's lack of resource of implementation. And after we install any plugin on also JDK, and we got some technical error, like we unable to connect to the third-party plugin because it is too old, and we have tried to find a lot of solution, but we still cannot get it out. By the way, we have learned a lot about it. We know that why it become like that, and because of the technology is too old, and although we cannot make it through this IDE. By the way, we also understand that when the smart card will look like if we have done the implementation. Now we come to the last part of the presentation and about the conclusion. In this conclusion, we conclude the difficulty. In this work, there are a lot of difficulties, such as lack of experience about researching. So it's hard for us to find some document and also read it out. And also lack of resource because smart card is an old, because it was created long times ago, and also time consuming. Also our difficulty because we spend a lot of time to understand the technology and also the use case. For the summary overall work, smart card have many different types depending on the term of use, and there are 15 parts of the standard ISO 2816, which part 11 is the base for preserving citizen identity. And smart card play an important role in order to preserve medical system too. For my future work, according to unsuccessfully implementing this project, I would like to have a chance to finish the implementation in future, and I wish to bring a better result for the next time to be a great result for future researchers. That's all for my presentation, and if you have any question related to this presentation, please feel free to ask.
Okay, thank you for your presentation. I see you have focused on the implementation part. Do you have a physical device, the real device, the card reader device?
Excuse me, teacher, can you hear me well?
Okay, I hear you.
Thank you for your question. Actually, we have the physical device for do this implementation, such as card reader. We have two type of card reader, and also the card for writer too. And for about the card, we have a Java card and also the ISO 7816 card too. That they are both they are based on ISO 7816 standard.
You mean you have two devices for the card reader?
Yes, teacher.
And then you try to implement it by installing the SDK, some plugin, and then you successfully implement it, or what?
Actually, I haven't successfully implemented, but I have connect the card with the computer and it's worked perfectly. Anyway, for the IDE and connect to generate some code into the card, we haven't successfully because maybe I need more time to do it more and working more on it.
And what is the problem that you cannot install your SDK?
I think it is about JDK and also about the IDE because the requirement that I have found on the resource on the internet, they require the version 6 of NetBeans, and actually NetBeans nowadays come with version 12 and also Java JDK too. For Java JDK nowadays is version 17, but they require Java JDK version 6. So I afraid that it doesn't work well with this process, but I will try to working more on it.
I don't know how long you work for your internship. It's 12 weeks.
Yes, teacher. But actually, for the part of implementation, we start about a month. Also with the report writing, because some use case and also the technology of smart card is new to me and also the member of smart card team. So we need to learn more about technology and also the key encryption or something.
Okay. Yeah, because you have a similar presentation and you focus on the same topic, I think I could understand and I know the scope of your project. That's all from me. Thank you for your presentation.
Thanks, teacher.
Okay, thank you, Daradat. My question would be the same to the previous member. What is your responsibility in this project?
Thanks, teacher, for your question. Actually, my responsibility is about to summarize all the part of the other member, and also I focus on uh, uh, figure out which card is the best for preserve the user, and also the citizen identity, and focus on about technology such as PKI and OSA and ECC comparison too.
So you mentioned here that this ISO 7816 Part 11 is the best. So why is it the best? Do you have any detailed comparison among the 15?
Thanks, teacher, for your question. And actually, it is the best because it supports the cryptography and citizen data management, and also it comes with the biometric method for the user. And actually, the other part doesn't have this function, and also doesn't secure like this part 11. And as my researching more about it, I found out it specify on the user identification, and also it have the key encryption of biometric method. It is a special case of this part. I hope I could answer you well.
Yeah. So you mentioned about in your implementation, you mentioned about the out of date software that is not compatible with the hardware that you use. So what about the hardware you use? Is it the new hardware device, or is it the old version device?
For the device, it is the new version device, but the requirement that I found on the internet, they need the old technology. So I cannot go far with this because the period of time is limited. So I just try to implement what they have mentioned, and the result is not it is unsuccessfully. And I believe that there are more technology related to the smart card that can make the improvement out, but I will try to searching for it later and to finish the implementation.
Okay. Okay. I think that's all from my question. Thank you, Dr.
Yes, thank you.
And for me, I don't really have any question since I got all the flow from the beginning already. Okay, so if there is no more question from our jury, so I think we can end the presentation now. Okay. So, and congratulations to every presenter for your hard work and effort. You guys really have done really great job for your presentation. Okay, thank you, and be prepared for your next for your next internship, which starts in February. Okay, and I really appreciate for those who are doing the research work. You guys start to do research work since year 4 on. You are so lucky than me. During my time, there were only a practical implementation in this time. We do not focus much on the research. but you guys now so lucky that you have your supervisor. He's doing research, so you guys can have chance to do research from the very beginning. Okay. Right. So thank you for today, everyone. And do you have any last comment, other teachers?
Mondra, maybe you can give some speech.
Okay. Okay. Yeah. Thank you all. And actually, this year I received 8 students for doing research, and 4 just finished last week successfully. Not last week, yesterday successfully. And these 4 are smart card teams. And I honestly said that the smart card is very, very difficult. And if it's easy, I think maybe many smart card application used in Cambodia or around the world, because smart card use not so much, and even they say like smart card, but they use only IC card, not the smart card 7816 part 11. And even, now the students work on the research on the type of smart card, but they don't learn about how the system work, how to protect the attacks, how to preserve the security and privacy. It's many more than this. So I appreciate your endeavor of the research, and your report are kept for the references for another researchers who will join the research lab next year, and for the master students. So you need to happy for to appreciate yourself also, that what you are doing is for the reference for other researchers and another researcher. So it's all of my comments, and thank you all judges. And I know that it's hard, it's difficult to follow the explanation, the presentation, because they are new to the research and presentations. Yeah, thank you. That's all from me to say. Thank you.
Yeah, okay, well, thank you so much. I don't have any comment. I just wish everyone happy holiday, and do your best for your next internship in year 5. Okay.
Thank you, teacher.
លោកគ្រូចង់មាន short discussion ចង់តិចអត់ឬក៏យើងអាចចាប់មក the jury sort
jury set ប៉ុន្តែផាយខ្ញុំបញ្ញាប់ទៅសាលាទីពីព្រោះខាងសាលាគេឲ្យទៅសញ្ញាឯកសារអីផាយខ្ញុំត្រូវចេញទៅតិចទៀតហ្នឹងហើយdiscussion ចាំយើងនេះហើយចាំយើង discussion សរុបបាទពេលក្រោយណាចាំខ្ញុំផ្ញើ link ចូលក្រុមតាមក្រោយ
បាទអរគុណច្រើន
So thank you so much for all jury and all students for today. Wish you a happy and safe holiday. So see you again on Monday, everyone.
Okay, bye everyone.
Okay, bye.
Thank you, teacher.
Teacher Wendy.
Bye.
Teacher check progression OS យើងនឹងឯចានណា teacher.
បាទមក
network security
បាទជា check នៅថ្ងៃច័ន្ទហ្នឹងហើយ
បាទ okay teacher thank you ជ្រាបលាលោកគ្រូ
Bye